Good afternoon, everyone. Welcome to this special session that we have organized to share the findings of our meditation research work that we've conducted over the past almost 4 to 5 years. The work has resulted in many research publications, and today our aim is to present these findings, and also to look at the next steps, as it were. Where are we going to do? What are we going to do next? How are these research projects going to be taken to the next level? Why we are looking at this is because there's a lot of interest these days on mental resilience. Different types of people have approached us to look at mental resilience. I mean, I can tell you, so for example, there is this worldwide belief that we may be heading for another world war. So how do you, maintain mental resilience of people in that kind of situation is something that everyone is looking at. And people, for example, military people who have heard about us, the fact that we are doing this type of work has reached out to us and asked us, what have you found? How can that be translated into resilience? As you know, if you look at those in military services, they have post-traumatic experiences, and therefore they want to, that's one group that they are looking at. And then recently, I had an interesting approach. I was approached by a group. Apparently, the fastest growing sports in the world now is esports. And we are probably not experiencing that here in Sri Lanka. But esports is growing rapidly in the West. And apparently, the people who are into esports spends hours of time, hours and hours and hours, engaged in repetitive activities in front of television screens. And what I was told was that if you look at typing speed, the fastest that any one of us will be typing is like currently 150 words or 150 keystrokes per minute. And the top esports athletes, they call them athletes, by the way, type at a speed of 650 keystrokes per minute. So from average to that. So as you know, like we were funded by the AHEAD grant. And one of the expectations of the AHEAD grant was that there will be a commercial product that comes out of the investment that they have. And they had invested, I think, on this group about 50 million rupees, right? That's what, 40 million rupees. A few years ago, when I go as dean, and some of these questions were asked from the deans, how can you, so I was really wondering, how can you say that what we are doing can be translated into a commercializable product? Obviously, we all have spiritual expectations. That's a different thing. But, we can't. Well, if you want to say, if I use the word liberate everybody, so you have to also get the other people who are in worldly pursuits, as it were, to benefit from this in their pursuit of worldly gains, if you want to call it like that. So therefore, I think what we are doing has a real impact beyond what one might see as spiritual gains. And so I think today it's a real opportunity for us to reflect on the findings of the research that has been done, and also to find out from the researchers themselves as to what they think are the next steps. And then, of course, the researchers who have now completed their PhD can kind of engage on the next steps, maybe as postdocs. And we can look at funding, which will enable their supervisors, with the researcher participating as a postdoc. And another set of, PhD is coming in to be mentored. So this is a kind of an enterprise that can grow. And I am very confident that there is funding, and there is funding which we can get both from those who are involved in the areas such as what I told you just now, as well as the philanthropic funding like what we have got now for the Center for Meditation Research, that will enable us to also translate what we are doing into educational programs, as well as going further, also from those who are involved in the spiritual pursuits as well. There's a lot of funding which is there, which we can tap into. So all these opportunities are there. So I think today is an opportunity for us to reflect on what we have done, chart out the future, and I will be happy to work with the entire team to work out what our plan is in terms of manpower requirements, PhD students, and others, and how we are going to, generate the funds for how we are going to generate the funds to support the next set of PhD students. And of course, I also believe that we need to now take it to even a higher plane where we are, even doing things like neuroimaging and so on. For that, we may need to establish collaborative links with others so that we can get the done and so on. I don't expect us to be setting up MRI facilities in faculty, which will be a wasteful investment just for one. We can always use the services that have already been set up in other places for a fee, and that is, I think, what we should be doing. We can also look at what kind of machines that are out there and available, what kind of enhancements sometimes they need to be done, and so on, to help our research. So what I mean, for example, is sometime back there was a study that was done on position of iron in the brains, I think, of children with thalassemia, and all that project needed was a little software upgrade to the software that is available in the MRI scanner and LRH. So people were at one point thinking, oh, we need to buy a new MRI machine with this. So all that needed was a little software patch upgrade, which enabled them to do that and publish that work. So these are some of the thoughts that are going through my mind, and so I'll be happy to support all of you with all this work that you are doing, wonderful work that you are doing, and we will look forward to listening to the researchers, and then also discussing the steps at the end. So let me hand you over to Professor Dimchani Dissanayake. She will maybe give you a lineup of who is going to talk and about. And because we have about 6 speakers, 7 speakers, so we plan to finish in about 2 hours. So therefore, we will strict on time, and also I think from the speaker's point of view, I think they are all ready to speak just to the point and what they think is very relevant, and we will support all of those who have joined. In fact, in this room, we have only 6-7 people. On the Zoom, I see many more, and 41 at the moment. So that's a large number. So thank you very much to all of you who have joined us on Zoom. We will, on our website, I think, carry all the papers coming out from this work. I think there are 9 or 10 journal publications that have come. We'll put those up on our website. So if you want to go further and access those papers, you'll be able to do that. Okay, so with those words, over to Dilshan.
Thank you very much, sir. So I'll give you a brief overview of the project and then we'll go on to the presentation in the interest of time. So this was a multidisciplinary project where we had researchers from different disciplines of the University of Colombo. So we collaborated with Faculty of Medicine, collaborated with Faculty of Science, Institute of Biochemistry, Molecular Biology and Biotechnology, Faculty of Arts, Faculty of Education, etc. The main objective was to look at the effect of meditation from genes to behavior. So we had 26 researchers, they are still with us, the research team, and 7 PhDs and 2 MPhils as well. So we had 2 phases of this project. In the first phase, it was a comparative case control type of a study where we recruited long-term educators. That was a hard part of the study because we had to develop a special tool to recruit long-term meditators, which we call as skilled meditators. So that was a gap in research when it comes to recruiting meditators for scientific research. So it took us almost 1 year to develop that tool. So it's a very specific tool to develop, which was developed to recruit long-term skilled meditators for scientific research. So using that tool, we recruited 30 long-term meditators, and then we recruited carefully matched 30 controls. So we matched almost all the confounders that we could think of. So that also took about 1 year to recruit that 30 controls also. So we had a carefully recruited 30 meditators and carefully matched 30 controls. So the first one was a comparative study in which we compared their genetics, epigenetics, immunity, neurochemicals, hormones, cardiorespiratory functions, neurophysiological functions, endocrine functions, GI functions, psychology, in relation to education, environment, sociology. So this is the first study in the world in which all these parameters were tested in one group of people or one cohort. So with that, now that phase is over, now we moved on to the interventional part of the study, through which we developed 4 intervention protocols, tailor-made targeted protocols aiming diseases and community. These protocols are also registered in our clinical trials registry, and 1 protocol has already been implemented and we have got the final results. The other one is almost over, and there 2 are ongoing. So that's where we are in relation to this project. So we, as Lee said, we got funding, large amount of funding, and the funding period is over. So with the funding, now we promised key performance indicators, we call it, around 49 key performance indicators, and we achieved about 64, and we successfully completed the project, and we have publications and protocols and lots of things happening. And these PhDs, we have 7 PhDs and 2 MPhils, supervised by different researchers in the university, and we traveled all over the university and we had meetings in the university. So this multidisciplinary nature of the project exposed us to different aspects of research related to meditation and its effects. So you will hear from these 7 PhD students today in relation to their key findings. Another objective of this type of activities is to disseminate our findings to larger communities. So we have done that before as well through the research project. We have symposia days, meditation days, full day retreats, and also we had monthly meditation program for the university community, and we have all these recordings available on YouTube, and we were on TV and newspapers. So in that way, we disseminated our findings, and we will continue to do so. And with that large amount of findings, we established research and service-oriented laboratories and centers through which we are planning to continue our research. Also, we have included some of these sophisticated instruments to teach and learning activities of the undergraduate students as well. Finally, because of the success of the project, according to the advisement by our team, we established a Center for Meditation Research, through which we are planning to collaborate, expand provide services, and also training. So currently we are running online meditation programs as well as on-site weekly meditation programs. And also we are looking for further funds, and we have visiting scientists. We have Professor Sharmali with us, who is planning on a big project. And also we have received some funds, especially from Reiki Foundation USA, and we are planning planning collaborative research, training, as well as this is a special course that we are planning, which is funded by the Reiki Foundation, which is called the certificate course on the science of happiness and meditation. Actually, the aim is to see how we can translate the science of happiness and meditation to our day-to-day work. So we'll be advertising that course also soon. So those are the things that quickly the project, how it evolved, and what we are doing so far. So the objective today is for all of us joining here as well as online to get to know as to what we have found through different aspects of the project. So first of all, we will be looking at how meditation affects genetics and epigenetics. For that, we have Nirodi Dasanayake.
I'm Nirodi Dasanayake, and my research topic is effects of meditation on genetics and epigenetics. My supervisors are Professor Nilakshi Samaranayake and Professor Nirmala Sirisayan. So, as an introduction, according to the previous studies, meditation and mindfulness techniques cause detectable changes to our body and mind. However, the underlying molecular mechanisms are still a question. In addition, most of these studies were looked at mindfulness-based techniques such as yoga, qigong, tai chi, etc. When we investigating these studies, we found that these studies were focused on a disease group such as cancer, obesity, infertility, and depression. And these studies were repeated in different countries with same technique or with different meditation techniques. And the results varied. Most interestingly, the biomarkers of the current scientific world, the most interesting biomarkers of the current scientific world are telomere length, expression of the genes, and epigenetics, especially the DNA methylation. According to the previous studies, we found that separate studies found changes in these markers with different cohorts. There were no studies which have been looked at all these markers in the same cohort, which enable the understanding of the molecular mechanisms involved. Through this research gap, we prepared our general objective to investigate the telomere length, gene expression profile, and DNA methylation status of selected genes of practitioners of meditation and mindfulness techniques compared to non-meditators. Under that, my specific objectives were to assess the telomere length and the plasma telomerase levels between meditators and controls. When we talk about the telomeres, they are simple tandem repeats located at the end of the chromosomes. The main function of this telomere length is to protect the chromosome end and maintain the cellular aging. Plasma telomerase is an enzyme. It controls the length. It maintains the length of the telomeres. And my next objective is to evaluate the expression of the genes that are related to telomere length, chromatin modulation, circadian rhythm, and inflammatory pathways. And my last objective is to access the methylation status of the promoter regions of the selected group of genes. Moving on to the methods, after the recruitment of participants, the blood was collected. From this blood, plasma and the whole blood was separated. From the plasma, we analyzed the plasma telomerase level, and through the whole blood, we extracted DNA and RNA. The extracted DNA was used to analyze the telomere length and the DNA methylation level. And through the whole blood, we extracted the RNA, and from this RNA, we analyzed the expression of the genes. For all these analyses, we used commercially available kits and golden standard methods. So moving on to the results. Moving on to the results, you can see the socio-demographic characteristics of the two groups. We recruited 30 meditators and 30 age and gender matched non-meditators. As you can see here, none of these socio-demographic characteristics were significantly different between the two groups. That indicates that we matched the two groups as much as possible. So, when we compare the telomere lengths between meditators and controls, we saw that the telomere length was significantly higher in meditators compared to controls. And when we then we compared the plasma telomerase level, which maintained the telomere length, and we saw that the plasma telomerase level was significantly higher in meditators compared to controls. Most interestingly, when the duration of meditation practice is increasing, the telomere length and the plasma telomerase level were also increasing. Then we compared the expression of the genes that are related to plasma telomerase. I mean the HTERT and HTR genes that are encode the plasma telomerase enzyme. So again, we found that the expression of these two genes was significantly higher in meditators compared to controls. Additionally, we found that when the duration of meditation practice is increasing, the expression of HTERT and HTR genes were also increasing. Then we looked at the expression of the circadian rhythm genes. So under circadian rhythm, we looked at two genes and we found that both genes were significantly highly expressed in meditators compared to controls, which indicates that the long-term meditation practice may have an effect on maintaining homeostasis of the body. Then we looked at the inflammatory-related gene expression, and we found that the genes that are related to inflammation showed significantly lower expression in meditators compared to controls. Again, we found that when the duration of meditation practice is increasing, the expression of the genes related to inflammation is decreasing. Then we compared the methylation level at the promoter regions of these genes. So, we saw that the HTERT gene, which encodes the telomerase enzyme, showed a significantly lower methylation in meditators compared to controls, which leads to a higher expression of the gene. Then we saw that out of these inflammatory genes, IL-6 and CXCL1 genes were significantly highly methylated in meditators compared to controls, which leads to lower expression of the gene. Though the other genes did not show a significant increase in the methylation, when we looked at each CpG site of these genes, we saw that 2 to 5 CpG sites were significantly highly methylated in meditators compared to controls. Most interestingly, the methylation level at the promoter regions of the significantly different genes, IL-6 and CXCL1 genes, showed a significant increase with the increasing duration of the meditation practice. So, this is the hypothetical diagram that we prepared to show the molecular mechanisms underlying to these molecular markers and meditation. So, as a summary, meditation as a lifestyle practice has multi-level beneficial effects on telomere dynamics with potential to promote healthy aging. It may stabilize the circadian rhythmicity, which contribute to maintenance of the body homeostasis. It may promote the downregulation expression of some inflammatory pathway genes, which leads to related inflammation in the body. It may also have the potential to increase methylation in inflammation-related genes, which can lead to reduced inflammation and decreased methylation in the telomere genes, which can promote healthy aging. So through this study, we can generate future studies to employ a larger sample size and prioritize a longitudinal study to better understand the effects of long-term meditation. And in additionally, we can investigate a specific patient groups, such as those with particular health conditions, could offer valuable insights into the potential therapeutic benefits of meditation on these molecular markers. So these are the articles that I published in peer-reviewed journals. And here are my abstracts that I presented in conferences. These are the awards that I won through this PhD journey. These are my acknowledgements. And thank you.
So James, now we will invite James Ambiraja, to talk about the effect of meditation on immunity, hormones, and neurochemicals.
Yeah. My study was to look at selected immunological, hormonal, and biochemical parameters of the stress response in experienced Buddhist meditators and non-meditators. And my supervisors are Professor Shiroma Hanunetti, Dr. Ilanthi, and Professor Dilshani. As you all already know, meditation has shown to have an overall positive impact on health, especially on the stress response. Its neurological benefits include stress reduction, decreased anxiety, and reduced depression. And we've also found out through literature that meditation affects immunological outcomes such as circulating inflammatory proteins, cellular transcription factors, gene expression, immune cell count, immune cell aging, antibody response. However, all these parameters, especially the immunological, biochemical, and hormonal parameters, haven't been collectively studied in one cohort. So that was the main objective of this study, that is to assess selected immunological, hormonal, and biochemical parameters of stress response in a Sri Lankan group of experienced long-term meditators, Buddhist meditators, compared to age, gender, and educational level matched non-meditators. So this was just a cross-sectional study, and we were looking at immunological parameters such as total antioxidant capacity, reactive nitrogen species, superoxide dismutase, glutathione peroxidase, catalase, and high-sensitivity CRP. And hormonal parameters such as adrenaline, serotonin, melatonin, cortisol, growth hormone, and glucagon, and neurotransmitters such as GABA, glutamate, and dopamine. So like I said, this is a cross-sectional case control study, and ethical clearance was obtained from ERC medical faculty. 30 skilled long-term meditators from meditation centers were recruited after screening using a validated intake interview, which was published as well. Age, gender, and educational level matched non-meditators were recruited as controls. So in order to assess the reactive oxygen species, we first looked at the total antioxidant capacity using the ABTS assay, and the parameter and glutathione peroxidase, catalase, and superoxide dismutase. All these enzymes were were assessed using commercially available ELISA kit from eLab Science. And then we looked at the total serum nitric oxide, that is the nitrates and nitrites together, using modified Grease assay. And we looked at the enzymes such as NNOS, that is neuronal nitric oxide synthase, inducible nitric oxide synthase, and endothelial nitric oxide synthase, also nuclear factor kappa B, all these using a commercially manufactured ELISA kit from eLab Science. Other parameters: adrenaline, dopamine, serotonin, melatonin, cortisol, growth hormone, GABA, glutamate, glucagon, high sensitivity CRP. All these were also looked at using commercially manufactured ELISA kits from LDN. When we look at the results, we found out that the total antioxidant capacity, superoxide dismutase, catalase, and glutathione peroxidase were all significantly higher in those who meditate. So these increased antioxidant capacity and oxide enzymes gives us an indication that meditation could decrease oxidative stress, which in turn could slow down aging and reduce risk of many cardiovascular diseases, neurological disorders, metabolic disorders, as well as maybe cancer. And we also found out that nitric oxide and these enzymes, INOS, inducible nitric oxide synthase, and NF-kappa B were significantly lower in meditators, whereas NNOS, that is neuronal nitric oxide synthase, and endothelial nitric oxide synthase was higher in the meditators, but not significant. These are an indication that this, like previously, decreases oxidative stress. Under hormonal parameters, we found out that serotonin and melatonin were significantly higher in the meditator group, whereas adrenaline, cortisol was significantly lower in the meditator group. This could be an indication that meditation increases relaxation and calmness, and as well as it lowers levels of stress. We also found out that GABA and dopamine was significantly high in the meditating group, whereas glutamate was significantly lower, which could be an indication that meditation regulates anxiety. So to conclude, we could say that the effects of Buddhist meditation on these parameters may have potential benefits in decreasing oxidative stress, psychological stress, depression, anxiety, and improving executive functions as individuals. And this study improves the awareness of traditional Theravada mindfulness meditation techniques on the human body and its application in medical practice. Currently, we are looking at correlating all these parameters and trying to find out or trying to assess a correlation between these parameters with respect to meditation, the meditating group. And one of our future aspects or future pathway of this project would be to conduct an intervention, since this was a cross-sectional study, to look at an intervention to assess the same whether meditation has an effect on all these parameters. And 2 articles have been published, one on the melatonin and serotonin levels, and the other on the nitric oxide and antioxidant capacity levels of the meditators, or this difference between the meditator group and the controls. And 7 abstracts, 2 in international conferences and 5 in local conferences were published. Thank you.
Thank you, James. Thank you very much for that excellent presentation and brilliant results. So we'll move on to the next presentation. Now we have looked at the genetics, epigenetics, cellular, and also molecules, neurotransmitters, hormones. Now we are going to move to systems. The first one is cardiorespiratory. Dani.
Right. So good afternoon to you all. So my study topic is an exploration of cardiorespiratory and autonomic function parameters in healthy long-term meditators. So my supervisors were Professor Diniti Fernando and Professor Lakmari Amarasuri from the Department of Physiology, Faculty of Medicine, Colombo. So giving a brief introduction to my study. So this meditation has been a recent topic in the field of psychophysiological research. And these physiological parameters are thought to improving regular practice of meditation. But there's a paucity of data. We identified that there's a paucity of data on cardiorespiratory and autonomic function changes with long-term practice of meditation, and hence this study was planned. So our study had 2 main objectives. First, to describe selected cardiorespiratory and autonomic function parameters in healthy long-term meditators in Sri Lanka compared to a group of 8 sex-matched healthy non-meditators. And secondly, to evaluate the associations between cardiorespiratory parameters and autonomic function parameters in healthy long-term meditators in Sri Lanka. So to achieve these objectives, we conducted a cross-sectional comparative study involving 30 healthy long-term meditators and 38 sex-matched healthy non-meditators. So all these physiological parameters we tested in our study can be broadly categorized into three testing components. First, the cardiorespiratory function testing component. Secondly, the physical performance and physical activity level component. And thirdly, the autonomic function testing component. So to start with the cardiorespiratory function testing component, we first assess the resting cardiorespiratory parameters of our study participants, including resting heart rate, resting blood pressure, resting ECG, and the resting respiratory rate, along with the resting spirometry and maximal breath holding time. Next, in the second testing component, we assess the changes of cardiorespiratory parameters during submaximal exercise using the 6-minute walk test. And using the resultant 6-minute walk distance data, we estimated the maximal oxygen consumption of our study participants. Then for better interpretation or for a better discussion of these collected cardiorespiratory data, we also assess the physical activity levels of our study participants using the International Physical Activity Questionnaire. Then under the third testing component, we assess the autonomic functions of our study participants using a battery of 5 non-invasive cardiovascular reflex tests, including the heart rate response to deep breathing, heart rate and blood pressure response to lying to standing, Valsalva maneuver, and the isometric hand grip test. So this is those were the three testing components of the phase 1 of our study. And in phase 2, we wanted to further look at the autonomic function changes of this long-term meditator cohort. And for that, we recorded the heart rate variability parameters in this long-term meditators at rest during a breath-based meditation session, which is Anapanasati meditation, and also during a controlled slower breathing session. In addition to that, we also assess the associations between resting heart rate variability parameters and tread mindfulness as assessed by the 5% mindfulness questionnaire to evaluate how these inherent or the pre-existing levels of tread mindfulness affect the resting autonomic function of the healthy long-term meditators. So we have, up to now, we have completed the full data collection of all phase 1 and phase 2, but we are still analyzing the data of phase 2. Hence, today I'm going to present the findings of the phase 1. So moving on to the result, first starting with the cardiorespiratory function component. The resting cardiorespiratory parameters, resting respiratory rate, resting heart rate, resting systolic blood pressure, and resting diastolic blood pressure were significantly lower in long-term meditators than they are non-meditators. In regards to the resting spirometry and the maximal breath holding time, the peak expiratory flow rate and the inspiratory breath holding time was significantly higher in long-term meditators than the non-meditators. In addition to those, we observed some significant associations between respiratory function parameters of these long-term meditators and some meditation practice variables, including their lifetime meditation experience measured in years and the retreat participation experience. So moving on to the results of the second testing component, according to the 6-minute walk test results, the 6-minute walk distance and the estimated maximal oxygen consumption did not differ significantly between the two groups. Considering the total International Physical Activity Questionnaire scores, the physical activity levels also did not differ significantly between the two groups. So next we'll look at the autonomic function component finding. So all those tested autonomic function parameters for the both groups, long-term meditator group and the non-meditator group, were within the normal limits for healthy individuals. So in regards to the test of sympathetic function, the diastolic blood pressure increase in response to isometric hand grip test was significantly lower in long-term meditators than the non-meditators. In regards to the test of parasympathetic function, out of the 4 tests, the Valsalva ratio was significantly higher in long-term meditators than the non-meditators. So next, fulfilling our second objective, we assess the associations between cardiorespiratory parameters and autonomic function parameters in healthy long-term meditators, and we observed some significant correlations between some of the cardiorespiratory parameters of long-term meditators and their autonomic function parameters as shown in these figures. So in summary, with the findings of our study, long-term meditators appear to have better cardiorespiratory and autonomic function compared to their matched controls. And also, long-term regular practice of meditation appear to shift the sympathovagal balance at rest towards the parasympathetic dominance in healthy long-term meditators. Moreover, the greater practice duration and repeat participation experience appear to be associated with improved resting respiratory function in these healthy long-term meditators. So with the results, we believe this knowledge generated from this study, which investigated the changes of cardiorespiratory and autonomic function parameters associated with long-term practice of meditation, holds promise for informing interventions for those with compromised cardiorespiratory function and autonomic disorders. Hence, we recommend future studies focusing on integrating meditation techniques into interventions which are targeted at improving the health outcomes of these individuals with those compromised cardiorespiratory function and autonomic disorders. So with that, we are coming to the end of my presentation. So with the findings of our study, we have to date published 2 original articles in peer-reviewed index journals, and we have presented 8 international abstracts. And we also, with the project funding, we have upgraded our cardiorespiratory research laboratory at the Department of Physiology, and we have established successfully a well-equipped autonomic function laboratory at the Department of Physiology. So these are my acknowledgements. So thank you all for listening.
Thank you, Dani, for that brilliant presentation and very interesting findings. We will move on to the rest of the presentations where we have the intervention part also included. So we had interventions on patient groups and also community. So I invite Dr. Kumarangi again.
Yeah, thank you, Professor Deshani. So I'm Kumarangi, and my research is on the effect of meditation on central and peripheral physiological parameters in health and on selected clinical outcomes of Parkinson's disease and epilepsy. So Professor Deshani Dissanayake and Professor Tershi Chang from Faculty of Medicine, University of Colombo are my supervisors. So straight away moving on to the objectives. My study was conducted along 2 phases. So the phase 1 was done using the same cohort that was discussed previously. So in my research using this cohort, I looked at the normal physiological parameters. So 4 normal physiological parameters: cognitive functions, electroencephalographic patterns or EEG patterns, visual evoked potential or VEP findings, and peripheral nerve conduction findings. Then using these data obtained out of this phase 1, we developed an intervention and implemented it on selected patient groups and assessed some of their outcomes in a randomized control trial. So that was my phase 2. So first about the phase 1 results. So in the 2, so this is a case control study, long-term meditators and matched meditation naive controls. So we've looked at cognition, visual evoked potentials on the 2 sides, then EEG patterns both at rest and as well during meditation, and peripheral nerve conduction findings. So as you could see, we have indicated in asterisks, there were significant differences obtained between the 2 groups. So higher scores were obtained by the meditators for cognitive data as well as for visual processing. So how fast what we see is being processed is being assessed in visual evoked potentials. And the EEG wave dynamics were significantly different during meditation, but we did see some differences in certain brain regions, in certain brain forms at rest as well. And similarly, the peripheral function of the nerves were also different. So the meditators had faster functioning nerves in their peripheral nervous system. So moving on to phase 2, a very brief summary of the methodology. So this is a randomized controlled trial. We used Parkinson's disease patients and epilepsy patients. So the data acquisition was done at 3 points: pre-intervention, mid-intervention, and post-intervention, but the intervention went on for 8 weeks. So the intervention was meditation-based intervention, which comprised 40 minutes of daily practice with guided sessions throughout during the period of intervention. The Parkinson's disease group, the data at the pre-intervention level was statistically insignificant to begin with. So Parkinson's disease, it's the second commonest neurodegenerative disease, and that has motor as well as non-motor manifestations. So I have looked at those both. So to start off with motor, I have used 3 tests to assess the motor functions. So SPS COPA is a study instrument, is a questionnaire-based tool, which is developed by the International Parkinson's and Movement Disorder Society. So this analyzes motor evaluation, activities of daily living, and motor complications. So in all my charts, what you see onto your left, it's the interventional arm, and what you see onto your right in each box is the control group. So when I say control group, so we are talking about Parkinson's disease, they receive their usual care. And the interventional arm, in addition to their usual care, they underwent the intervention. So as you could see in all these motor parameters, the meditators had the interventional group had improved motor functions. So the improvement means the reduction in the score. So whereas the control, the usual care alone arm had worsening of their scores. This worsening in terms of motor evaluation and activities of daily living was statistically significant. Then further motor analysis using time up and go test. So the time up and go test improved in meditators in the interventional group, though it's not statistically significant. Whereas in the usual care alone, the control group, the TUG test worsened, and that worsening is significant. Then further motor analysis using peripheral nerve conduction, where we looked at the conduction velocity and the amplitude in the tibial nerve in both the sides. So both the conduction velocity as well as the amplitude improved in long-term meditators, and it deteriorated in the control group. Improved in the interventional group, and it worsened in the control group. So in this nerve conduction study, the improvement in the interventional group and the deterioration in the control group are both statistically significant. Then moving on to non-motor assessment in the Parkinson's group. So this non-motor assessment was done using the tool SENS-PD, which stands for severity of non-dopaminergic symptoms of Parkinson's disease. Again, it's a tool owned by the MDS Society. Looked at 6 non-motor functions: cognitive functions, psychotic functions, postural instability and gait dysfunction, excessive daytime somnolence, autonomic system dysfunction, and depressive symptoms. You could clearly see now these non-motor functions, apart from psychotic symptoms, have improved in the interventional arm. Whereas all the functions, non-motor functions, have deteriorated in the usual care alone or the control group. And this deterioration is significant for psychotic symptoms, autonomic system dysfunction, postural instability, and gait dysfunction. Then moving on to the second patient group, which is epilepsy. As in Parkinson's, the data at the onset pre-intervention was statistically significant between the two groups. So we've looked at, so epilepsy is a condition where there is unprovoked seizures. So we've looked at the seizure frequency. So as you can very clearly see here, in the interventional arm, following an 8 weeks of intervention, the seizure frequency has significantly reduced. Whereas in the control group, it has remained more or less the same. And this reduction here is statistically significant. So in summary, 8 weeks of meditation-based intervention has shown to improve significantly motor and non-motor functions in Parkinson's disease with a significant reduction in seizure burden in epilepsy. Some of my presentations and the awards I have received during this period. And so I'll take this an opportunity to acknowledge every single individual who has helped me to sail through this journey. And thank you.
Thank you very much. Shamila has looked at the metabolism activities.
Thank you very much. We looked at the effects of meditation on metabolic health in healthy individuals and in patients with type 2 diabetes. And my supervisors were Professor Priyadarshini Kalapathy, Professor Prasad Katulanta, and Professor Saroj Darsingha. And as you know, meditation is intentional self-regulation of attention involving focused attention, self-regulation, and awareness. And with these meditation techniques, it has been shown to have metabolic benefits, and they are through neurohumoral modulation. And there's also evidence that healthy meditators, there's favorable metabolic parameters, and even short-term meditation has shown to improve glycemic control in patients with diabetes. So with this background, we first looked in the same cohort, a comparative cross-sectional study to look at the baseline metabolic parameters, where we compared the healthy experienced skilled meditators with that of age, sex, and education matched healthy non-meditators, and a systematic review and a meta-analysis to look at the mindfulness, meditation, and glycemic control in type 2 diabetes. And then we moved on to a randomized control open-label clinical trial where we looked at effects of meditation on physiological and metabolic parameters in patients with type 2 clinic diabetes mellitus. So in phase 1, what we saw was the mean duration of continuous meditation in long-term meditation were 6.6 years. And the both groups were similar, and we did not find any difference in their mean. So they are healthy people. Their baseline glycemia and body mass index were not statistically different. And although the meditators had slightly better cholesterol profile in terms of total cholesterol, LDL, triglyceride, it was not statistically significant, and more meditators were found to have desirable LDL as well, but not significant. So we went in to do a systematic review and meta-analysis where we looked at 360 articles, and after removal of duplicates, we sort of analyzed the data, and full text articles, the number was 41. And after removing the ones which were not fit into our inclusion and exclusion criteria, we analyzed 14 studies, which showed a significant HbA1c reduction in 6 out of the 8 randomized control trials. And in the random effects model of analysis, the test for oral effect was significant and favoring experimental group with a combined effect size of minus 0.26. But there was significant heterogeneity and possible publication bias as well. In our clinical trial, where we looked at the effects of meditation on physiological and metabolic parameters in type 2 diabetes, we had the objective of looking at some of the metabolic parameters and physiological parameters, mainly to look at the glycemic control and other metabolic parameters, as well as look at some physiological and metabolic parameters which are in the pathway that contribute to hyperglycemia in terms of looking at how this can happen. So we have interviewed more than 400 patients, and over a period of 1.5 years, we were able to select patients with type 2 diabetes within 5 years of diagnosis, not on insulin, into our trial, and 64 patients were randomized in group-wise, where 32 went into the meditation arm and 32 were wait-listed. And baseline investigations were done, and in the meditator group, they underwent, they followed this mindfulness meditation protocol, which was developed with the expert meditation instructor, which was pre-tested and piloted as well. And this included mindfulness walking, mindfulness breathing, mindfulness sitting and eating, and it included both guided on-site sessions as well as non-guided meditation. And we had online sessions as well over a period of 12 weeks, and a recorded version was given for their guidance at home. So, so these are the parameters we assessed. The glycemic control was assessed with the HbA1c, fasting blood sugar, and fructosamide, and fasting serum insulin and insulin resistance was calculated, and lipid profile, then 24-hour urine cortisol, and some of the GI hormones like ghrelin, GIP, GLP-1, and leptin. And physiological parameters, autonomic function testing according to CARDS protocol, and heart rate variability and body impedance analysis, and orocycle transit time using hydrogen breath analysis. So the baseline demographic factors are not different in the two groups: age, number of years of diabetes, number of diabetes medicines, and MOCA. So to assess the baseline cognition, we had very strict criteria to enroll into this trial, because we were analyzing a lot of parameters, and we are still entering the data and going through the later part of the analysis. And one of the interim analysis showed the HbA1c, there was no difference in the two groups. Both groups showed a reduction of HbA1c, but it was not significant. In the lipid profile, the meditators showed a reduction. The non-meditators showed a slight increase, however, it was not significant. But there was an increase in good cholesterol, that is HDL, among the meditators, which was statistically significant. So we are still analyzing the other data, and the observed trends would be we showed the long-term meditators seems to be having a favorable lipid profile, and the meta-analysis clearly showed there's significant reduction in HbA1c in the pooled data, and the preliminary analysis in the RCT data also showed favorable lipids in the meditated group, and when compared to the wait-listed group. And although it's too early to conclude, but as Kumarangi said, there was very good uptake on the meditation program. And when we offered the meditation to the wait-listed group also, because it was carried out in group-wise. And as Professor Ishani told, people from all the ethnicities participated, and they were happy. And these were some of the publications out of the study. And I would like to thank the World Bank and all the participants who had to come 2-3 times to our department to carry out these investigations, and the technical staff of the Department of Physiology, my supervisors, Professor Ishani Sanaika, as well as the Center of Meditation Research. Thank you for your patient listening.
Thank you, Shamila. Well done. Well done for the presentation as well as for exciting findings. We're still analyzing data, so we'll get more exciting results on the way. Now we'll invite Omela. Omela will be discussing about the psychological effects and intervention on chronic kidney disease patients.
Hello, everyone. I'm Omela. Me and my supervisors, Dr. Santushi Amarasuriya, Senior Lecturer from the Department of Medical Humanities at the Colombo Medical Faculty, and Dr. Jeevani Herath, Senior Lecturer from the Department of Social Science Education at the Colombo Education Faculty, are a part of this meditation research group of the University of Colombo, and also the wider project titled Meditation, Mindfulness and Health. So as a part of this project, we engaged in empirically exploring how meditation may play a role in the psychological health of human beings. So meditation practices, irrespective of ethnicity or religion, are somewhat familiar to us as Sri Lankans. And meditation in simpler terms is understood as a practice that fosters attention, awareness, and insight in those who practice, and also thereby results in mental states of calmness, concentration, and relaxation in them. While meditation is practiced in multiple ways, predominant meditation practices in the country consist of concentration and insight meditation. However, unlike in the Western context, there are a multitude of empirical evidence discuss the effects of these practices. Evidence generated in the local context is at its early stages, and therefore it calls for scientific understanding. Also, the anecdotal benefits of meditation from our own country context sort of further motivated us to learn more and use this evidence base to implement a meditation-based intervention to complement existing clinical practices related to psychological health. With all this in mind, we developed a study which consists of two phases. During the first phase, we aimed at exploring possible differences between skilled meditators and their age and gender matched non-meditating controls in terms of a number of chosen psychological parameters which are actually key to mental health. So these were levels of mindfulness, psychological resilience, perceived quality of life, and also psychological distress. And informed by these findings of this first phase, our second phase entailed developing and administering a meditation-based intervention to address psychological distress and quality of life of chronic kidney disease patients. The selection of this particular clinical sample was because chronic kidney disease, or CKD, is a prominent non-communicable health concern in Sri Lanka at the moment. And also, interestingly, psychological health of patients is actually viewed to affect their prognosis and also affect their adherence to treatment regimens, which are actually often psychologically taxing. Keeping in line with our objective, our first phase study was developed as a cross-sectional and correlational study with a participant number of 64 skilled meditators and 64 age and gender matched non-meditating controls. The skilled meditators were chosen through a two-tier screening process. First, they had to be individuals who were between the ages of 18 to 65 years and also had been practicing meditation for a period of more than 3 years, and also those who were following meditation practices taught in Sri Lankan meditation centers, monasteries, or temples headed by Buddhist monks or nuns. And second, they were screened through an intake questionnaire which was developed by the larger meditation research group. Previous presenters also discussed about it. And the age and gender matched non-meditating controls were recruited from the community using purposive sampling. Individuals who were obtaining psychiatric or psychological assistance during or since the past 5 years, and those who were practicing other methods of relaxation such as yoga, Tai Chi, and Qigong were not used in either group. Upon providing informed consent, the participants completed the singular versions of the 5-facet mindfulness questionnaire, the resilience scale, the abbreviated version of the World Health Quality of Life questionnaire, and also the depression, anxiety, and stress scale. We conducted an interim analysis, and I would like to share the findings with you today. First, we conducted a cross-sectional analysis with data collected from both the meditator and non-meditator groups, and we found that the meditator group showed significantly higher levels of total mindfulness and also its five skills in terms of describing, observing, acting with awareness, non-judging of inner experience, and non-reactivity to inner experience. We also found that the meditator group showed significantly higher levels of psychological resilience and also perceived quality of life in terms of physical health, psychological health, social relationships, and environment. Also, they showed significantly lower levels. Earlier it was higher levels, and now they showed significantly lower levels of psychological distress in terms of levels of depression, anxiety, and stress. Moving on to our correlational study, where the skilled meditators alone were considered, we saw that their mindfulness skill in terms of non-reactivity to inner experience was significantly and positively correlated with their duration of meditation practice, which we measured using the number of years of practice, and also the frequency of their meditation practice, which we measured using the number of meditation hours they practiced per week. Also, their meditation skill of observing was seen to significantly and positively correlate with their duration of meditation practice, which, as I said before, was measured in years. Based on these findings, we concluded that skilled meditators may show significantly higher psychologically protective factors, which we identified as mindfulness and psychological resilience, and also perceived quality of life and lower psychological resilience, denoted by lower levels of depression, anxiety, and stress compared to their non-meditating counterparts. We also concluded that higher duration of frequency of meditation we also concluded that high duration and frequency of meditation practice may correlate with higher levels of mindfulness in terms of non-reactivity, while higher frequency of meditation practice may correlate with higher levels of mindfulness in terms of observing. So, after all of this, we paired these overall findings of phase 1 with extensive literature searches and in-depth interviews to develop our proposed meditation-based intervention as the second phase of our study. Since the intervention focuses on patients with CKD, our interviews were conducted with physicians treating them and also CKD patients who were already meditators. Through these interviews, we further explored practicalities of conducting a meditation-based intervention with the short clinical perception. Based on our findings, explorations, and also guidance from expert meditators from our own research team, and also those whom we consulted from outside, we developed a meditative psychotherapeutic intervention, which is aimed towards alleviating psychological distress and improving the perceived quality of life of patients diagnosed with CKD. The proposed intervention will be tested using a randomized controlled trial with the participation of patients diagnosed with renal failure and are experiencing psychological distress. All of this, of course, which we will be assessing during recruitment. To tell you a little bit about the intervention, it will be administered through 8 weeks with weekly 1.5-hour hybrid sessions, that is, sessions held on site and online, and will include 3 meditation methods: walking meditation, body scan meditation, and loving kindness meditation, and will be conducted by expert meditators. While 56 participants will be administered with this intervention, another 56 individuals will be allocated to a control group where they will participate in a parallel series of illness-related education sessions with similar interactions with the researchers. Both groups will complete a set of questionnaires pre and post intervention, and also after a period of 3 months after completing the intervention. And data obtained from both intervention and control groups through these questionnaires, and also journal recordings from intervention group participants, will be analyzed to explore the effects of the intervention alone as well as compared to the control condition. So currently we have registered our trial at the Sri Lanka Clinical Trials Registry and are on the process of approaching and recruiting candidates for our study. We hope to conduct a pilot study first and subsequently to conduct the trial. These are some of the references I used for today. Some of the achievements, publications, and short communications that came through our component. Grateful for the study participants who contributed with their time and support, my supervisors, Professor Dirshani, and the nephrology unit at the National Hospital of Sri Lanka, and also the head project of the World Bank. Thank you very much for listening.
Well done, Amela. Well done for your brilliant presentation as well as for all the hard work. Sandhini, thank you for waiting. Now it's your turn to talk about meditation and its effect on connectedness with nature, carbon footprint. So we are moving to environment. Okay, Sandhini.
So very good evening to all of you. I'm Sandhini Somaratna. I'm representing Faculty of Science, University of Colombo. I registered there as a PhD student and I investigate on pro-environmentalism and meditation. My PhD is supervised by Professor Arundhati Lokupitiya from Faculty of Science, University of Colombo, and Professor Vasantha Gunatunga from Faculty of Medicine, University of Colombo. So I know that some of you are not much familiar with the term pro-environmentalism, which I used here in my research title. Actually, this is very novel research area in the scientific world today. Hence, at the beginning of my research presentation, I would like to introduce some key terms which I am going to use throughout my presentation. So the first word is pro-environmentalism. So it's basically about improving environmental conditions while paying attention to reduce negative impacts on the environment. Under this concept, or else under this term, we can explore both environmental attitudes and environmental behaviors. In our study, we explored both environmental attitudes and environmental behaviors. In relation to environmental behaviors, we considered climate change mitigation. Therefore, we focused on per head carbon footprint, which can be defined as one's greenhouse gas emissions to the atmosphere. Actually, we need greenhouse gases to maintain living temperatures in our world, but exceeding a certain limit may cause for various negative impacts such as global warming and extreme climatic conditions. To study environmental attitudes, we followed the theory on connectedness to nature. It's about one's implicit and explicit attitudinal connection with nature. As you can see on this slide, the number of research on these aspects in the present world, in the present scientific world, is very low. Especially till 2019, there was only one published research article on the role of meditation in greenhouse gas emission. There was no research on exploring this aspect in a Sri Lankan context. Even the meditation is one of famous cultural practices in our country. Therefore, in 2019, our team, with the support of Professor Dirshani and the World Bank, started to explore this aspect. On this slide, you can see the objectives of our study. Initially, we divided our study into two phases, phase 1 and phase 2. And the first three objectives were explored under the phase 1 of our study. Under the phase 2 of our study, we are exploring cultivating green lifestyle, CGL intervention, which was the major outcome of our phase 1. So phase 1 of our study was a cross-sectional exploratory study. We explored skilled meditators who practice Vipassana meditation continuously for more than 3 years and who can maintain continuous attention on the meditation object. In the analysis of the study, as major independent variables, we studied temporal variables of meditation. That means duration of practice of meditation and frequency of meditation, along with the trait mindfulness. And as major dependent variables, we studied per head carbon footprint under 4 domains. Those were traveling, solid waste disposal at residence, food and beverage consumption behavior, and electricity consumption at residence. And as well as a dependent variable, we explored connectedness to nature. Under that, implicit connectedness to nature is one of the dependent variable we explored. It means one's trait attitudinal connection with nature, and explicit connectedness to nature means one's experiential connection with nature. Apart from those variables, we collected data on positive lifestyle habits of skilled meditators and perceived quality of life. Phase 2 of our study is a randomized control trial, and currently the CGL is being explored among corporate sector employees. As I mentioned earlier, as this was the first scientific study in Sri Lanka, we had to develop some scientific tools to study our study variables or as our parameters. As my colleague mentioned, UOC IISL was one of the significant outcome of our whole project, which can be used to identify experienced and advanced meditation practitioners for future scientific studies. Buddhist meditation experience questionnaire, BMEQ, is also such kind of questionnaire based tool, and future scientific researchers can be used it to collect data on positive lifestyle habits of meditators. We define positive lifestyle habit as a behavior, deed, or as attitude that a person desires to adopt and incorporate it into his or her lifestyle because of its beneficial outcomes. The Sinhala version of the connectedness to nature scale will be the first scientifically validated tool in Sri Lanka to study one's experiential connection with nature. It was a translation of Professor Mayer's connectedness to nature scale. And the IAN, Implicit Association Test for Nature Connectedness, was originally developed by Professor Schultz and his team, and it is a computer-based test to identify one's implicit connection with nature. On this slide, you can see some publications on the tools we developed and validated, and a full research article on connectedness to nature scale, Sinhala version, is currently under processing. Here, I have summarized the significant relationships we could found through the statistical analysis. So, temporal variables of meditation and trait mindfulness was significantly correlated with explicit connectedness to nature. The test values for the implicit connectedness to nature test were between plus 0.15 and plus 0.86, which indicates meditators are more connected with nature than built environment. Even if the temporal variables of meditation were not significantly correlated with per head carbon footprint, trait mindfulness, which was a variable of meditation, was significantly correlated with carbon footprint. Apart from this, significant findings, as you can see on this slide, we saw significant relationship between temporal variables of meditation and trait mindfulness, and between trait mindfulness and perceived quality of life, and as well as we saw a significant relationship between perceived quality of life and carbon footprint. And not only that, as we saw significant relationship between mindfulness and carbon footprint, as well as mindfulness and positive lifestyle habits, we thought to go in depth into these relationships. So we conducted Hayes process for mediation analysis to identify the mediation role of positive lifestyle habits on the relationship between facets of mindfulness and domains of per head carbon footprint. We could find that positive lifestyle habits plays a partial mediation role between observing facet of mindfulness and carbon footprint based on food and beverage consumption, and as well as positive lifestyle habits plays a significant partial mediation role between the relationship mindfulness acting with awareness, it's a facet of mindfulness, and carbon footprint based on solid-based disposal behavior. Hence, based on our results so far, we have these conclusions, according to the conclusion we have, meditation experience significantly correlates with explicit connectedness to nature and per head carbon footprint associated with travel behavior, solid waste disposal behavior, and food and beverage consumption behavior of a skilled meditator. And as well as positive lifestyle habits partially mediate the relationship between meditation experience and per head carbon footprint. So And I presented my research work at several national and international conferences. And here you can see the references of my publications and awards I received. And here are some more. And there is a data article a data article in Helion under review. As well as a preprint of that article has been published. And currently I am in the phase 2 of my study, and I am exploring CGL, our intervention, and also the protocol of the intervention was published in Sri Lanka Clinical Trial Registry, and the protocol article of the CGL has submitted to an international journal, Sustainability. So at the end of my presentation, I would like to thank all study participants, my supervisor, Professor Dilshani Disanayake, and as well as the head team and World Bank. Without their support, I may not be able to come this far in this journey. And at last but not least, I would like to thank all for listening to my presentation. Thank you.
Thank you, Sandhani. Excellent presentation and a lot of hard work there and our findings in the area of research. We have a few minutes for questions. I think what we have seen so far is that we had a carefully selected group of long-term meditators based on the outcomes of meditation. Mainly the tool was developed based on the neurophysiological and neuropsychological outcomes. So we selected a special group, and then we got a carefully matched control, and we looked at changes from genes, molecules, body systems, behavior, and behavior towards the nature. And then we did some interventions on patient groups, and also we're planning more interventions on community groups. So this is the summary of our findings, and we have scope for more future research. And thank you, Professor Vadira, joining again.
I must say, I was listening all along. So I think like the question that we really need to ask is, what have you found which is not described by anybody else? I think each one of the PhD students can tell us or look at their data, look at the currently available literature, and tell us, okay, what have you found which is not described by anyone else? I think that is of value, that we need to focus on that. And so if everybody can give some feedback on that, and of course, what is the next step? That is something that did not actually come out of the presentations, where the students were focusing on describing what they had done. But I think we also need a slide on what is the next step, what the next step that they think. And so if they, I think the supervisors and the students can tell us what is unique about your research project, what is the next step, then we can look at what I said earlier, that is, okay, now where is our next, who are we going to approach for our next level of funding? What are we going to do with it? Yeah. So I think that's important. So I had invited a few strategic thinking people to listen, and actually that's the feedback I got from them while the discussion was going on. And so because if we have that, then we can work out the plan next on what our kind of funding is going to be. And so you all would have given some thoughts on what. So that is what's pitch going to be to NIH. Is it you're looking at? I think we are, we are at the beginning of something unique. We need to kind of work out the value proposition, and also work with people who have worked on that translation picked a lot, and they, some of them who I had invited were there in the audience today. We can have a discussion with them also. So shall we close this session? It's 4:30. We've had 2.5 hours of interaction. Thank you very much to all the participants who joined us on Zoom. We'll take this forward, and maybe we also create the meditation, the bigger meditation session. We can bring more people coming in and meet every month also, and having discussions and so on. Yeah. So thank you very much then for all our students who made the presentations, those supervisors and others who joined us here on site and online. All right then. Thank you very much.
Thank you.
Okay, we'll meet you once again in another session.